Compound probabilities using lists, tree diagrams, and tables. Say that 5 times fast. For this assignment, you will not only need your Desmos calculator, you will need your fraction calculator, and then you will definitely need something new. I just spent some time trying to figure out, again, how do we do this away from our yellow TI-84 graphing calculators. And I found out that you need to Google something called the calculator soup, shout out to our friends again, combinations calculator. We'll use that for the very end of our assignment. So have that open, pause if you need to get that up, and then click back to Desmos, and let's dive in right away. The first, most really of the problems on this whole assignment use what's called the multiplication principle of counting. And it says very wonderfully that if you want to know how many combinations you have of different objects, you just figure out how many options you have on each individual object, and then you multiply. That's why it's called multiplication principle of counting. You multiply it all together. So I always say that my favorite thing to tell students to do with this is go into your closet, figure out however many shirts you have, however many pairs of pants. Maybe you want to break it down even further, shorts. And then you've got your shoes and your socks and your underwear. All your different items. And I don't know, I'm just going to write numbers down here. Say you've got all these different numbers that represent how many shirts you have, how many pairs of pants you have, how many shorts, underwear, socks, shoes. You could have another category for hats or watches or whatever kind of stuff you wear, scarves. And then you multiply all of these together, and that represents how many total outfits you can wear. And it's going to be a huge number. It's going to be so large that if you wore a different outfit every day, it would take you years to wear all your clothes. Even if you don't think you have that many clothes, it multiplies fast. And then you start getting new clothes after a while, whether you have a birthday, a holiday, or just, you go by Goodwill or something. All of a sudden, it just keeps growing. And so that is a fascinating application of the multiplication principle of counting. It makes me think about how, this doesn't take into account matching. In college, I had this famous outfit where I sort of learned what matching was the hard way. I had these bright orange shorts, this bright red t-shirt, like these yellow shoes, and I got these just weird stink eyes walking around campus. And finally somebody came up to me and was like, "Bro, what are you doing? You can't do that. You can't match red and orange and yellow." And I said, "What? Why not, man? This is my fire outfit." Then I started trying to match a little bit more, but as you all know, not a lot. I got my go-tos, my Hawaiian shirt Mondays, my tie-dye Tuesdays, Western Wednesdays, all that kind of thing. All right, diving into our assignment after that little anecdote, let's utilize the multiplication principle of counting by taking each individual thing that you have and multiplying it together. So the very simplified version, as if you only needed hats and shoes to wear, you'd still basically be naked, walking around with hat and shoes. But if you want to know how many combinations of outfits you have with just 4 and 2 items, 4 hats, 2 pairs of shoes, you just multiply them together. 4 times 2. Very simplified version of the multiplication principle of counting. And that's what you get. Number 2 says a person rolls a number cube and tosses a coin. There are blank possible outcomes. So once again, we got to figure out how many items do we have and how many combinations on each item. So a die has 6 sides times how many are in a coin. 6 times 2 is 12. And I believe every single person, that's one of those free ones you get. Number 2 is 12. Number 3, a person spins 2 different spinners. There are blank possible outcomes. Well, on this spinner, there's 4 outcomes. And then I can multiply that by this spinner are 3 outcomes. And I get 12. The next one you got to pay close attention to because we definitely could have different numbers here. So it says a person chooses 1 cone. Now I've got only sugar or waffle. You might have cake or other types of cones. 1 scoop of ice cream. Again, I only have 2 combinations. You might have more than that. And 1 topping. Once again, I only have 2 combinations. You might have more than that. So for me, it's just 2 times 2 times 2, or 2 to the third power, which is 8. 2 times 2 times 2, 2 to the third power, or 8. For you, again, just multiply all 3 numbers that you have in each of your examples of dessert categories, and you'll get your answer. 5 says you are buying t-shirts for your sports team. The shirts come in a variety of colors. So how many combinations do I have in each of these items? So let's see. Blue, red, white, green, or yellow. That's 1, 2, 3, 4, 5 options for that. And can be either short-sleeved or long-sleeved. That's just 2 options. So I've just got simply 5 times 2, or 10 for that one for me. Should have a similar thing going on for yours. 10. Okay. Number 6. Jar A contains 1 marble. Each of the colors blue, red, pink, and white. Blue, red, pink, and white is 4 colors. Jar B contains 1 marble. Each of the colors black, gold, copper, and silver, also 4. Jar C contains 1 marble. Each of the colors green, orange, yellow. That's 3 colors. So I've got 4 times 4 times 3, or 16 times 3 is 48. Do the same thing for your problem. 48. Okay. Number 7. A person picks a card 1, 2, 3, 4, 5, 6, or 7. Well, 1 through 7 means there are 7 choices there. Tosses a coin. Already went over that. It's 2. And rolls a number cube. Already went over that. 6. 7 times 2 times 6 is 14 times 6, which is 84. Let's do the same thing. How many cards you have times 2 times 6? 84. That is the number of one of my favorite athletes, Randy Moss, old receiver for the Vikings. Also Patriots and later Raiders, but 84 was his Vikings number. A person tosses 3 coins. There are blank possible outcomes. Okay, this is one to really watch out for. It's what I just had a few problems ago. 2, 2, 2. We have 3 coins. We know we have to multiply. The problem is many people, instead of multiplying, will add them. They'll be like, 2, 2, 2 is 6. Great. And 2 plus 2 plus 2 is 6. But that's not what we want. We want 2 times 2 times 2. Or as I said before, 2 to the third, which is 8. If you have 2 coins, you're going to get lucky because 2 plus 2 is the same as 2 times 2. But for anyone else, do 2. Here is where your power button is, this little A to the B right there. Sounds like a rap. A to the B. And then how many coins you have, write that as your exponent. So 3 coins, I get 8. If I had 4 coins, 5 coins, but for me I just have 3. And we're going to use this for the next few problems, at least definitely for 10 and 11. I forget what 9 is. Oh, skipped ahead. Let's go back to 9. Person rolls 2 number cubes. There are blank outcomes. Okay, so now instead of there being 2 possibilities on each thing, there are 6 possibilities. And we still need to hit that exponent button. So put how many cubes you have. I've got 2, so I put a 2 up there. If you have 3, you put a 3. 4, you put a 4. For me, it's 36. For you, it might be a number larger than that. All right. Now is where we need to utilize our calculators. I hope that you have pulled these up. If not, press pause now, Google calculator soup, and get your simplifying fraction one, which I always think you should have in case you need it, and then your combinations calculator, because we have a couple challenging problems now. Number 10, toss 3 coins. The probability of tossing exactly 2 tails is blank. The reason this is called combination or compound probabilities using lists, tree diagrams, tables, you can write out with 3 coins all the possibilities. Tails, 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 heads, tails, heads, 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 on and on until you've written out all your possibilities. And then you could simply circle the ones that have exactly 2 tails and then write it as a fraction. But I want to teach you how to do it using this combinatorics button. So hopefully you have opened up this calculator. The first thing you need to do is figure out the denominator of your fraction. So I'm going to clear everything because we're getting complicated here. Just like we had before, take however many coins you have, and that's what we're going to use. So type in 2, everyone's going to have 2, and then how many coins you have determines your exponent. So I've got 3 coins, so that's 2 to the 3rd power, 8. All right, then I'm going to go over to my fractions button, simplifying. That number you just got, 8 or 16 or 32, put in the denominator. That is going to be what we have there. But we need to figure out our numerator. And for this problem, my numerator is tossing exactly 2 tails. So if I have 2 tails, there's a button on our graphing calculator called the NCR button, where we'd say, all right, I have 3 coins, I want exactly 2 tails, spit out a number of how many combinations that would be. Because we don't have that calculator, I found another one, the combinations calculator, where here you type in the number of objects, the number of coins you have. So for me, I've got 3 coins. And then you type in where it says exactly how many tails, like I've got 2, so I type in 2 here. Then I hit calculate. This is going to tell me my numerator. So my numerator is 3. So then I can go back to my fraction and say, all right, a numerator of 3 over a denominator of 8, does that reduce? It does not, but for you it might, depending on what kind of problem you have. You put in your simplified fraction, and voila, you get it right. So you could either write out all the combinations like I started to do and circle the ones and then reduce that fraction, or you can do it the way I just showed you. 11 is a kind of bonus problem. That's why it is technically non-graded, but I wanted to show you how to do it. It says toss 4 coins. The probability of tossing at least 2 tails is blank. The fastest way to do this, honestly, would go backwards. If I wrote out all the possibilities and I just subtracted the amount that weren't at least 2 tails, so the amount that was just 1 tails, that would be easiest because there are only a few possibilities when I toss 4 coins where I don't get at least 2 tails. Most of the time I will. But to keep with this explanation, let's follow each step. So I've got 2 to the 4th. I will have 16 possibilities on my 4 coins. So I write that on my denominator. And then for my numerator, this is going to be complicated. There's not a button we can press that calculates at least. So we're going to have to do that manually. So at least 2 tails means out of 4 coins, I have at least 2. So exactly 2, calculate. So I've got 6 options there. I'm going to have to remember that number. Or maybe I can just go over here. 6. But then I'm going to have to add that with the at least 2 means I could also have 3. So 3 out of 4 gives me an additional 4 possibilities. And then finally, I could have all 4 be tails because that's at least 2. And that is only the 1 possibility. Tails, 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 tails. So I end up with a total of a numerator of 11. So then I can go back to my fraction and I could say 11 out of 16. Does that reduce? And because 11 is prime, it does not. So my answer is going to be 11 out of 16. If this is way too complicated and you try it a few times and you're frustrated, don't worry. This is just like a bonus challenge problem. I want to show you what to do if you're in that situation. You could also write out the combinations or just subtract the combinations that don't work when you write them all out and get it those ways as well. All right, I opened this a little while ago. It luckily did not take us 40 minutes. I'd opened it first and then spent a long time trying to figure out which calculator to use, how to use it, make sure I did before I taught it. That's just the work of a good teacher, which I try to be every day as often as I can be for each of you. Much love, best of wishes. Until next time, hopefully you've learned some things, if nothing else, about combinatorics and combinations on calculators. Take care and have a great day.